back. Okay, 13b is a straightforward or a factual stuff to test whether you remember the textbook problem, the textbook stuff clearly or not. Okay, B1. Okay, state one example of how large a refracting telescope has led to scientific discoveries. It means that we discovered something, we saw something. Okay, you can say we observe what we observe by large refracting telescope. Maybe you can say just some extra solar planet. Okay, we have find out because it has a high resolution, and also we find a massive black hole at the center of a Milky Way. Something very funny. Okay, so it is our discovery or other thing. Any other thing about the high resolution of large refracting telescope is okay. So next one is outline why a chromatic aberration is less significant in the refracting telescope. Remember, chromatic aberration is due to the spreading out of light when it go through the medium, right? So in normal telescope, it go through the lens. Inside the lens, they have refraction, different speed, right? So they spread out. So they have chromatic aberration. But for refracting telescope, no refraction, right? So low chromatic aberration. So you have to say first of all, chromatic aberration, where does it come from? Okay, chromatic aberration is due to the difference of speed when moving into a medium. But refracting a telescope does not involve refraction. Okay, so you say very clearly, right? So less significant. Okay, 2 points. Okay, what is a chromatic aberration and why refracting telescope does not has it or less significant? The third one you need to remember Newtonian mounting and classical mounting. So Newtonian mounting, remember when the lights fall inside, reflecting, and then there is a plane mirror, and the path go up, right? So you have to observe from here. Very strange, okay? Not along the way of the star. So this is the difference of the paths of the light rays. So later on, classical makes another adjustment. So the light will go through it, okay? Refracting, and make a hole, okay? Go through the mirror, and you can observe here. So the classical is more lateral, okay? You observe at the direction, okay? So what can you say? You can say, I suggest to say this. You can say in your right. It's okay. In classical one, okay. In classical, the final path of light is parallel or along, okay, along the direction of the star. While in Newtonian, you just distinguish them clearly. When in Newtonian, it is perpendicular. So it is the strength for the Cassegrain mounting. Let's check anything wrong, okay? That's it, okay? Remember, revise what you have learned, okay? Good job.